Hello, Professor. Myself, Srinivas Kamireddy, and my teammate Reshma Satyavadu. We are gonna submit our final project together. This is our presentation, like presentation slides. And before starting with our presentation, I just wanted to show you our IPNB file and HTML file that we'll be submitting. So let's start with our presentation. Uh, Good morning, Professor. Our project is titled Anomaly Detection Using Autoencoders. In this project, we worked with the inpatient hospital charges dataset. The main purpose of this project is to identify hospital records that look unusual compared to the majority of the data. These unusual records may have very high charges, very low payments, or abnormal relationships between charges, payments, Medicare payments, and number of discharges. This is the roadmap for my presentation. Now we will first explain the dataset and what kind of information it contains. After that, we will describe the data cleaning steps and the new features that created. Then discuss the exploratory data analysis or EDA to understand the patterns in the data. Finally, we will explain the autoencoder models, compare the results, and show how the final anomalies were identified. The dataset used in this project is the inpatient hospital charges dataset. It contains around 163K records and originally had 12 columns. The dataset includes provider details like a hospital name, city, state, zip, code, etc. It also includes medical category information through the DRG definition column. The main numerical columns are total discharges, average crowded covered charges, average total payments, and average Medicare payments. These columns are important because they describe hospital billing, payment, and the patient volume patterns. Before doing analysis or modeling, I cleaned the dataset. Some column names had extra spaces and removed leading and trailing spaces. To make the code easier and avoid errors, the financial columns were originally stored with dollar signs and commas. So we converted them into numerical values. Also converted total discharges into a numeric column. After that, checked for missing values in the important columns. Since there were no missing values in the key modeling fields, we were able to continue without dropping many records. First, for the task, we created 10 new features from the existing columns. These features were designed specifically to help with anomaly detections. Some features measure differences such as the gap between covered charges and total payments. Some features measure ratios such as covered charges compared to total payments. Also created per discharge features to adjust and payments based on the hospital volume. Finally, we used log transformed features to reduce the effect of very large extreme values. These new features help because anomalies are often hidden in relationships between columns, not just in one raw column. For example, a hospital may not have the highest covered charge overall, but it may have a very high charge compared to the actual payment received. Ratio features help identify this type of pattern, but discharge features are also useful because hospitals with different patient volumes should be compared more fairly. Law features help reduce skewness, so the model can learn normal patterns more effectively. In the EDA summary statistics, we observed that many financial variables are highly skewed. For example, average cover charges are generally much higher than the average total payments. This means hospitals often bill much more than what is actually paid. We also notice large standard deviations, which shows that the values vary a lot across hospital records. These wide ranges and extreme values are important because they suggest that anomaly detection is suitable for this dataset. The distribution plots show how the values are spread across the dataset. Most records are concentrated in lower ranges, while a small number of records have very high values. This kind of right skewed distribution is common in financial healthcare charge data. These extreme values are automatically wrong, but they are important to investigate because they represent unusual billing or payment behavior. The box plot provide another way to see extreme values. In this dataset, the box plot show many points far away from the normal range, especially for covered charges, charge payment difference, and charge to payment ratio. These points are possible outlier candidates. This visual evidence supports using an autoencoder because the model can learn the common patterns and assign higher reconstruction error to the records that are very different. The correlation heat map shows that the numeric features are related to each other. Payment related variables are strongly correlated because they measure similar financial behavior. The log transform features also preserve the general pattern while reducing the skewness at the same time. The ratio and difference features add extra information that is not fully captured by the original columns. This confirms that the new features provide useful signals for anomaly detection. Now my teammate Reshma will continue.
Hello, Professor. This is Reshma. Now I will walk you through state level charge patterns. So it shows the average hospital charges vary by state. Some states have higher average covered charges than others. So, however, a high charge is not automatically an anomaly. The autoencoder looks at simple multiple features together before labeling a record as abnormal. Next, charges versus payments. This scatter plot compares average covered charges and average total payments. The plot shows that bill charges and actual payments do not always increase equally. Some records must have much higher charges compared to other payments, which is one of the key patterns used for anomaly detection. The autoencoder method is a neural network that tries to reconstruct its input. It's an encoder that compresses the data and a decoder that reconstructs it. Normal records are reconstructed well and have low reconstruction error. Unusual records are harder to reconstruct, so they get higher reconstruction error. Autoencoder models tested. We tested three different encoder models. The first was basic encoder, the second was deeper encoder, and the third we used was dropout and L2 regularization. So all models used mean square error as the reconstruction loss. The best model was selected using validation loss. Here we compares validation loss across the three models. Model 2, the deeper encoder, has had the lowest validation loss. This means it reconstructed validation data better than the other models. So we selected model 2 for the final anomaly detection results. Here in the summary table, it compares the training loss, validation loss, threshold, anomaly count, and anomaly percentage. Since the threshold was set at the 95 percentile, each model identifies around 5% of the records as anomalies. Model 2 was chosen because it was performed best on the validation loss. In the final anomaly detection results, we using model 2, the final result identifies 8,154 anomalies records out of 163K total records. So this is exactly 5% of dataset. These records had the highest reconstruction errors and were considered the most unusual hospital charge records. In the reconstruction error distribution, this plot shows the distribution of reconstruction errors. Most records have lower reconstruction error, meaning they follow normal patterns. The red dashed lines is the anomaly thresholds. Here in the visualization, the difference between normal records and anomalies records using charge and payment attributes. The anomalies shows unusual relationships such as very high cover charges compared to payments or abnormal payment ratios. These visualizations help justify why those records were labeled as outliers. In the top anomaly examples, we conclude that the autoencoder successfully identified unusual hospital billing and payment behavior. Features engineering helped reveal important patterns such as gaps, ratios, and per discharge values. So, Model 2 performed best, and the final anomalies present the most unusual 5% of the hospital records. Thank you.